Welcome to Web Handling. My name is Dave Roysum. This is a continuation of our mini-series on safety. In the first clip, we covered case histories of accidents. Then we covered codes. In the last clip, we discussed how to use a risk assessment process to identify hazards. In this clip, we talk about human factors. The motivations to study human factors are many and strong. It is humans that are being hurt. It is human factors that are almost always involved. I have 5 helmeted hobbies and take safety quite seriously for all. I literally go to school on the subjects. For example, I learned as a private pilot that 80% of all accidents are due to human error. Simply running out of gas or flying into low visibility weather are the most common subcases here, and both are easily avoided by careful planning of each flight. The remaining 20% are due to mechanical failures. You can check out the crash of my experimental aircraft at night over a city to see an example in that category. While these statistics given here are for aviation, they are quite similar for car accidents as well as industrial accidents. Operators and any other people on the floor need training, recurrent training, and testing. As a private pilot and FAA Part 107 commercial drone operator, as well as an ACA certified whitewater kayak instructor, I needed initial certification as well as recurrent training and testing. To be current, you needed to be checked out on a 2 to 4 year schedule, but more frequent is even better. Safety manuals and procedures are sometimes provided by the machine builder. If not, an engineer teaming up with a lead operator should write them up. This should cover lotto points and procedures for that machine as well as how-tos for common operations such as threading and slitter blade changes. Manuals should be available at the machine, and the contents in those manuals would serve as the subjects for recurrent testing. Safety drills should be practiced regularly. Recall the first clip in the series where an operator was nearly killed because his buddies forgot where the e-stop switches were in the panic of the moment of a serious accident. Weekly safety discussions cover concerns, incidents, and best practices. This also helps keep safety at the top of everyone's mind. A squawk sheet is a great way for anyone to note a safety concern or safety-related maintenance item on a machine. I have visited about 1,000 plants in my 40-year career and have seen quite a variety of safety training standards for visitors. They varied from nothing at all to a full hour-long video with test and an annual expiration. In general, the bigger the company, the more extensive the safety training. It is most efficient for all if this can be done online before the visit. This saves a lot of time versus having it done in the guard shack at the 8 o'clock rush hour while your host is waiting. One of my most favorite of the many programs I learned as a pilot was the I Am Safe practice. This may save your life because of the riskiness of non-commercial aviation and because the proportion of the accidents due to human error are so high. However, motorcycles are also similar. Both have a lifetime risk of death of about 1%. Both are largely caused by human error. Industrial accidents are, fortunately, a bit less common, but still show similar trends. Illness. Even such minor human conditions such as a headache or tummy ache distract attention away from machine hazards. Medications. Even many over-the-counter medications will ground pilots. Most prescription medications require a specific aviation medical sign-off on a case-by-case basis. For example, blood pressure medications are as common as dirt and save lives. Yet they can occasionally induce lightheadedness, making them potentially quite hazardous when operating machinery. You can't guess which medications are safe for you. Only medical doctors reviewing your specifics can. Stress, much like illness, distracts attention from hazards. This can be everyday occurrences such as getting in an argument with a spouse, a teenager coming home with a detention, money problems, getting called into the boss's office, and on and on. We covered the 3 aviation rules for alcohol in the first clip. Perhaps the easiest to teach for machinery is the 8 hours bottle to throttle rule. Detectable alcohol or recreational drugs is cause for grounding. Finally, any impairment, even as minor as a hangover, much like illness or stress, increases personal hazard. Fatigue is a topic we will cover in the next slide. Education is a factor at both extremes. The inexperienced are not familiar with every single hazard they might run into. The veteran will be more complacent because they ran a machine for years in a more complacent environment than is current practice. Since they had not gotten hurt doing something yet, they presume the activity is not so risky, or that they have the skills to avoid it. Finally, I will add one of my own. Attitude. Don't take chances just to get the job done or production out the door. Don't show off. Respect machinery as having the potential to harm, even when it is stopped. We covered some aspects of good workstation ergonomics in a previous series. These included things like operator control panel placement and layout. We even covered such mundane elements as chairs and mats. Here we will highlight some aspects of fatigue. Most people experience insomnias at one time or another. An insomnia is a collective term for any time a person has difficulty falling or staying asleep for the 7 to 8 hours that most adults require for peak performance. There are scores of books and even courses you can take on the subject. Shift work is just one ingredient for insomnias. Merely working at night is contrary to the circadian rhythm that most mammals is aligned with sunlight. We add to this trouble if we rotate shifts that is the industrial equivalent to jet lag. We add even more to this trouble if we rotate the shifts backward, as is common in the U.S. This contrary schedule is often called the southern swing shift. This is contrary to the circadian rhythm that tends to be a bit more than 24 hours, not a lot less. All of this contributes to a higher accident rate and a higher divorce rate for shift workers than for other schedules. Long hours are trouble as evidenced by countless accident studies. The FAA allows pilots a maximum of 9 hours of duty during the day and 8 hours at night. This must be followed by a rest period of no less than 10 hours, of which 8 hours must be available for uninterrupted sleep. Commercial vehicle rules are governed by the NTSB in the US and are slightly less stringent but similar. Finally, physical fatigue from any number of sources, including noise and other stressors, increases personal risk. And again, the fine print. The web handling world is quite wide and circumstances can vary enormously. What I've given here is just a starter set of considerations to help keep you guys safe. Take these, modify them, and add to them what might make even more safe sense for your own machine and your own plant. Thank you so very much for watching this module in my Plant Practical series. Stay tuned for the next clip where we will continue our discussion of the chain of events that might happen during and after a serious accident.